All right, so today we are going to go over the first part of Chapter 6. Chapter 6 is all about what we call the normal model or the normal distribution. The normal model or normal distribution is basically your classic bell curve that you may have seen in past math classes. Remember, a bell curve is called a bell curve because of its shape. Um, it's unimodal and it's symmetric. So any histogram that is unimodal and symmetric is considered a normal distribution or a normal model because it looks like a bell curve. Most of our standardized test scores, whether it be the MAP or the ITEDs or whatever they call it now, your ACTs, any kind of standardized test, those scores are usually normal in nature. If you were to graph all the scores, they would most likely look or resemble a bell curve. You have, a few people that do really well, a few people that do not so well, but most of the scores are somewhere in the middle, and that's what a bell curve or a normal distribution is. This is the notation that you'll see commonly used for a normal distribution. Obviously, the N stands for normal, but these two symbols here you may or may not have seen before. These are actually Greek letters that are commonly used in statistics. The one that looks like a U is actually the Greek letter mu, and that is the symbol commonly used for the mean. And this one right here is the Greek letter sigma, and that is the common symbol that or notation that is used for standard deviation. So whenever you see this notation here, here's an example. Whenever you see that notation, the number that's first given is your mean, and the second number that's given is your standard deviation. Okay. Kind of the first thing we talk about with normal models and bell curves are what we call the z-score or the standardized value. A z-score does not have any units. What do I mean by that? When you measure someone's height, you usually measure it in feet or inches. You can measure it in centimeters. A z-score does not have any units like that. A z-score or standardized value is a measure of how many standard deviations a data value is from the mean. So we all know what the mean is. The standard deviation is how spread out the data is from the mean. A z-score for a particular value will tell you exactly how many standard deviations that particular value is from the mean. So for example, if you have a data value that is below the mean, below average. So for example, if you take a standardized test and the score that you get on that test is below average, that means the z-score is negative. A positive z-score is obviously the exact opposite. So if you take a standardized test and your score is above average, if the data value is above the mean, that means you have a positive z-score. And if your z-score is zero, if your z-score is zero, that means that data value is exactly equal to the mean. So if you took a standardized test and your whatever score you got was exactly the same as the mean, then you would have a z-score of zero. Okay, and what z-scores allow us to do is it allows us to compare different sets of data. So, for example, if I had a list of standardized test scores from different schools or different states or different classes, if I had different sets of data and I wanted to compare them, I could use z-scores to allow me to do that comparison. Now, how do we find z-scores? Very simple. If you have a data value and you want to find its z-score, this is how you do it right here. Okay? If you have a data value, you want to find the z-score, you subtract the mean, and then you divide by the standard deviation. And you subtract the mean, divide by the standard deviation, and whatever answer you get, whatever number you get, that is the z-score. That tells you how many standard deviations the original data value is from the mean. Okay, and I'll show you some examples in a minute. The question is, what if I want to go backwards? Okay, what if I start out with a z-score, but I want to figure out what value yields that z-score? Well, in math, we know that if we want to go backwards, we have to not only do the opposite operations, but we do them in the opposite order. So going backwards in math means do the opposite operations in the opposite order. So if I start out with a z-score and I want to go backwards, I'd first come here, but the opposite of division is multiply. Then I'd come here. The opposite of the opposite of subtract is to add, and then I would end up with the data value that yielded that z-score. This may not make much sense as I'm explaining it right now. I think it will make more sense as I go through a couple of examples on the next couple of slides. So let's do that. So how are we going to use this in terms of problem solving? Here's an example. Okay, on one test, your class achieved an average grade of 80 with a standard deviation of 8 points. All right, so we have our mean and we have our standard deviation. If you got a 96 on that test, what is your z-score? And explain what it means. So again, the 96 is like the data value, and I want to find what z-score that is. So going back to the previous slide, that's going to be this step right here that I'm circling with the cursor. So I would take the data value and I would subtract the mean. In this case, the mean is 80. So 96 minus 80 is obviously 16. And I take that and I divide it by the standard deviation. So 16 divided by the standard deviation of 8, and I get 2. So that 2 is the z-score. Okay. So the answer to the question, what's your z-score? Z-score is 2. What does that answer actually mean? And let's face it, that is what's most important. That 2 means that your 96, the 96 you achieved on that test, is 2 standard deviations above average. Okay, just to give you an idea, if you get 2 standard deviations above average on a standardized test, that is exceptionally good. Okay, so that score is 2 standard deviations above the mean. Here's another example. Your best friend got a 76. What's her z-score? And explain what it means. Okay, so now our data value is 76. Obviously, 76 is below the average. So we would expect that the z-score be negative for this. So we're going to follow the same steps. We're going to take the data value, the 76. We're going to subtract the mean of 80. That's negative 4. So there's where the negative comes in. Then take that, and we're going to divide it by the standard deviation. Well, negative 4 divided by 8 is going to be negative a half, negative 0.5. So your z-score is negative a half compared to positive 2 up here. So what does that negative a half means? Okay, that negative a half means that score of 76, which we already knew was below average because the average was 80, that score is a half of a standard deviation, so 0.5 standard deviations below the mean. Why below? Because the z-score was negative. So here you have an example of a positive z-score, meaning my data value, in this case the 96, is above the mean. And then down here we have an example where the z-score is negative because the data value, the 76, was below average, below the mean. Okay. Let's continue on with this concept here. Again, same test. Your class average achieved an average grade of 80 with a standard deviation of 8 points. Now we're going to do something different. What test grade has a z-score of 1.5? So this is that going backwards thing I was talking about a couple of slides ago. So what essentially I'm asking is what data value, okay, what data value, if I do these steps here, subtract the mean and divide, what data value is going to give me a z-score, an answer of 1.5? Okay, so because I'm starting with the z-score and ending with the data value, let's go back to a couple slides ago. Okay, because I'm starting with a z-score, I'm going to do these steps here. So I'm going to take the z-score, I'm going to multiply by the standard deviation, and I'm going to add the mean. Opposite operations in the opposite order. So let's go back to this example. So take the z-score of 1.5, I multiply it by the standard deviation. 1.5 times 8, I got 12. Then I add the mean, and I got 92. Okay, so what that means is that if you got a 92 on this test, that your z-score would be 1.5. Okay. Here's another one. What grade results in a z-score of -2? Okay, what grade results in a z-score of -2? So again, I'm going backwards. I'm starting with the z-score. I'm trying to figure out what data value is going to give me an answer, a z-score of -2. So I'm going to follow these same steps, the backward steps. Multiply by the standard deviation and add the mean. So in this case, -2 times 8 is -16. -2 times the standard deviation. Then I'm going to add the mean. Okay, so -16 plus 80 is 64. So that means if you got a 64 on that test, that your z-score would be -2. And again, we would expect that z-score to be negative because 64 is below average. So that's kind of an example of how we calculate z-scores and how we go backwards. You'll see several examples of this on your Math Excel assignment. Okay, here's a second example. Remember before I talked about how z-scores can be used to compare two different sets of data. So this is an example of what I'm talking about. All right, we have two different sets of data. We have data for calories, and notice we have our mean and our standard deviation. And our second set of data has to do with the fiber content. And again, we have the mean for that and the standard deviation for that. So two totally different sets of data with their own mean and their own standard deviation. Okay? So a serving size of a box of cereal in your pantry has 50 calories and 10 grams of fiber. Which is more unusual, the calorie content or the fiber? Okay. So when we want to do a comparison like that, when we want to compare two different items, in this case, the calories and the fiber, we're going to do that by looking at their z-scores. In other words, I need to find the z-score for calories and I need to find the z-score for fiber. So for calories, okay, our calories, Okay, we take our data value, we subtract the mean, so 109, and then we take that and divide it by the standard deviation. And notice I got a z-score of approximately negative 2.6. Okay, so that means that that box of cereal, that calorie content is 2.658 standard deviations below average. Okay, now I'm going to do the same thing for fiber. So I'm going to take that same box of cereal, its fiber content, which was 10, and I'm going to subtract the mean for fiber, which in this case was 2.7. I got that. Then I'm going to divide by the standard deviation, which was 3.2, and I got a z-score of positive 2.281. Okay, so which means the fiber was 2.281 standard deviations above average. Now, to figure out which is more unusual, and this is what the word unusual means in statistics, to figure out what's more unusual, we want to look at which z-score is farther away from zero. Okay, so if I were to put negative 2.658 and 2.281, positive 2.281, if I were to put that on a number line, which one is going to be farthest away from zero? Okay, in this case, that's going to be this one right here, the calories. Okay, whichever z-score is farthest away from zero, that is the one that is more unusual. So in this case, the calorie content would be considered more unusual because its z-score is farthest away from zero. So you will see a similar question like this on your Math Excel assignment where you have to make a comparison. You make the comparison by calculating the z-scores for both and then looking at which one is farthest away from zero. That is going to be the more unusual one. Okay. In general, in statistics, something that is considered unusual, okay, statistically unusual, you might hear that word. Okay, anything that is unusual means that that data value is more than 2 standard deviations away from the mean. So a piece of data that is considered unusually high, okay, if a piece of data is unusually high, that means its z-score is greater than 2. It's more than 2 standard deviations above average. It's the opposite for unusually low. If you have a data set and a particular piece of data that has a z-score that is less than -2, we would consider that piece of data to be unusually low. Okay, so anything that is unusual in statistics is more than 2 standard deviations away from the mean. The word rare in statistics has the same meaning, except it's 3 standard deviations. So in stats, any piece of data that is more than 3 standard deviations away from the mean is considered rare. So that would mean if a piece of data has a z-score that is greater than 3, we would consider that rarely high. And if the z-score is less than -3, meaning more than 3 standard deviations below, we would consider that rarely low. Okay, so this is an important thing to remember. All right, unusual means more than 2 away. Rare means more than 3 away. Okay, so how will this work in an example? Okay, here's the last example that we'll look at, and then we're done. So on the 5th grade state standardized test, the mean score was 125 and the standard deviation was 15. What score would be considered unusually low? Okay, so remember, unusually low means that the z-score is going to be less than -2. Okay, more than 2 standard deviations below. So unusually low means more than 2 standard deviations below average, which means our z-score has to be -2. Okay, so to figure out what score is unusually low, that means we would have to figure out what test grade would yield a z-score of -2, which means we're going to do the go backwards thing from before. Okay, we're going to take the z-score, in this case -2, we're going to multiply it by the standard deviation, and we got -30. Then we're going to add the mean, and we get 95. Okay, so that means any test grade of 95 or lower than 95 would be considered unusually low. Okay. Last part, what score would be considered rarely low? Okay, so remember, rare means the same thing as unusual, except with 3 standard deviations instead of 2. So rarely low means more than 3 standard deviations below average, which means we need to figure out what test grade is going to give me a z-score of -3. So I'm going to literally do the same thing, except I'm going to start with -3 instead of -2. So -3 times the standard deviation. I get that. And I take that answer, -45, add the mean, and I get an answer of, that is not 95. That is a typo. Okay. That is actually 80. Okay. Actually 80. Glad I picked up on that. So we get an answer of 80. So that means if you got an 80 on that standardized test, that would be considered not unusually low. That would be considered fairly low. So I did the same thing I did before, except with 3, and obviously I corrected my typos there. So on this particular test, based on this data, all right, any score of 95 or lower would be considered unusually low, and any score of 80 or lower would be considered rarely low, because it would be more than 3 standard deviations below average. Your Math Excel assignment for this particular part of Chapter 6 will have similar examples to what you saw. So as you're going through the questions, if you get confused, my first suggestion would be to go back and either look at that section of this video or just look at the PowerPoint itself and see how I did these examples.